So last time I did a video on matrix addition, subtraction, and scalar multiplication and finding determinants. Today I'll be doing a video on matrix multiplication. So this is basically multiplying two matrices, right? So let's just create two matrices. This is matrix A and this is matrix B. We have two matrices with us, right? Yes, but one rule we must keep in mind when we're multiplying the matrices, like when we're adding or subtracting matrices, both the matrices should be similar, right? In this case, the only one rule that we need to keep in mind is that number of columns of A must equal the number of rows in B, right? So columns, I'm going to write C subscript A. So columns of matrix 1 must equal rows of matrix 2. So columns of A must equal rows of B. So we must keep that in mind before we start making these matrices. Okay, so let's have two columns here and two rows here, right? So let's just go ahead and create our matrices, right? So this has to have two columns. So let me just put some random numbers here, maybe 2, 0, 1, 3, 4, 7. So this has two columns and three rows, and I need to have two rows here, right? So I'll just make it again, put random numbers 1, 3, 1, 3, 5, 4, 2, 9. Okay, so those two, that is very close. I'll just erase that. I'll do that again, maybe. Yes, better. So this is, let's make it 2, 4, 9, so that those two twos don't come close to each other. And now we're supposed to multiply these matrices, right? So how are we gonna do that? Yes. So first of all, let's look at what the dimensions of the resulting matrix will be. So I'll call this R subscript AB because this is the resulting matrix of multiplication of AB. So this is just some notation I use, right? Okay. So now let's look at how many rows this has. So this has two columns and three rows, right? Let's look at this. This has two rows and three columns, right? So the resulting matrix will have the number of rows of A and the number of columns of B as its dimension. So in this case the dimensions will be 3R and 3C. So there will be 3 rows and 3 columns, right? So now let's multiply these matrices. So what we do here is that we take the element that is present in A, we take the element that is present in the row of A, and then we multiply with the element that is present in the column of B, right? So now what we do is, this is row of A and this is a column of, so my things are touching a bit today, but we'll just ignore that. Yes, so we'll multiply the row of A with the column of B. So we'll take 2, we'll multiply it by 1, and then we'll take 2, we'll multiply that by 1, multiply 2 by 1, and we multiply 0 by 2. So I'm circling the two elements that I am multiplying, right? And what we end up with here, is, so we'll add these, we'll get 2 plus 0, right? So the resulting answer here is 2. So 2 will go up, 2 will go right up there. So by there I mean 2 will go here. And then we do this again for each of the rows that are present in B, right? So let me just clear some of this clutter up. Okay, let me just clean some of this clutter right here so that we can perform the multiplication on the next sets of numbers. Yes, so moving on, we take okay, so we take 2, we take 0, and then we multiply it with 3 and 4 respectively. So we do 2 times 3 plus 0 times 4. So what we get is 0 plus 6, and the result is 6. So 6 goes in here, right? Moving on, so we just have to do this again and again. So I'm doing this one, for that you can gain an idea of how these work. So then we multiply 2 with 5 and we multiply 0 with 9. So 2 with 5 and 0 with 9. So what we end up getting here, this is 0, this is 10, so we get 10. So that goes here, right? And then we do this for each of the rows and columns that are present in matrix A. Sorry, for each of the row that is present in matrix E, we multiply with each of the column that is present in matrix B. So we take this row which is present in matrix A and then we multiply it accordingly with each of these columns, and then we write the result here. So for the next row, I'll work quickly. So we multiply 1 with 1 and 3 with 2 to get the result as 6 plus 1, which is 7, right? So yeah, basically now we have to do this again and again. So it's 1 into 3 plus 1 into 4, which is again surprisingly 7. And then we have 1 into 5. So this is the second row here being multiplied by the last column by 3 into 9, sorry, plus 3 into 9, which will give us 27 plus 5, 32. And so we can also do it for the last row, but now I'll just write the answers down because you might have an idea of how it works, or I'll just go ahead and do this too, so that it is helpful. So let me just erase this. Yes. Okay. Now I have 4 into 7 and I'm going to multiply it with each of these columns one by one, right? So first it is 4 into 1 plus 7 into 2, which gives us 14 plus 4, 18. Let's put the plus sign, 18. Then we have 4 into 3 plus 7 into 4, which gives us 28, 12, which gives us 40. And then we have 4 into 5 plus 7 into 9. This is the last one, which is, okay, I'll clear the clutter a bit there so that you don't confuse it with this one or that one, right? Yes. So 20 plus 9 into 7 is 63. We get the answer as 83. So this is the resulting matrix. So this is how matrix multiplication works.